All right, welcome back. We're going to do a little polynomial division. You'll notice if you looked at the last video that this is exactly the same problem except I've tweaked it slightly. The last constant in the numerator is now a different number. So I'm doing that so that we show that you can get a result, a quotient, that has a remainder. In the previous problems, all of our work has neatly come out to having no remainder, and you know when you divide numbers that sometimes there is a remainder or a fractional component that is part of your quotient. So let's set this up as long division like we do. So we put our numerator, 10x squared plus 11x minus 3 under the division symbol, and we put what we're dividing by out here, 2x plus 3. We need to ask ourselves what times 2x gives us 10x squared so that that term cancels out when we subtract. Well, 5x times 2x is 10x squared. 5x times 3 is 15x. And we're going to subtract that. So we get 10x squared minus 10x squared is 0. 11x minus 15x is negative 4x. And we still have these three holes right here. Okay, so then the next question is, how many 2x's does it take to make negative 4x? Well, it takes negative 2. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. And when we subtract that amount, we get negative 4x minus itself is 0. Negative 3 minus negative 6, minus a negative is positive, so negative 3 plus 6 is 3. Now we have 3 left. I'm still dividing, right? Every step along the way I'm dividing by this 2x plus 3. I have 3. I can't make 3 out of x's because this term doesn't have x's. So our remainder would be 3 if you wanted to write it with a quotient and remainder format. However, that's not super helpful. Usually for polynomials, what we want to do is say, well, we are still adding this 3 and dividing it by 2x plus 3. So now this expression, it's not a polynomial because we've got a fractional component. We've got x in the denominator, so this is not a polynomial, but it is the quotient of this polynomial divided by this other polynomial. So we can write our solution, our quotient, as 5x minus 2 plus the fraction 3 divided by 2x plus 3. Now, it's important whenever you divide polynomials that you pay attention to the denominator. The denominator cannot equal 0. And we saw in the last video that if 2x plus 3 can't equal 0, that implies, this symbol means implies, that x cannot equal negative 3 halves. So we have to make this condition. We say, here's our quotient, except that x cannot equal negative 3 halves. If x equaled 3 halves, this denominator would be 0, and that part of our quotient would be undefined. And we're done.